All right. Thank you for the introduction. And thank you for having me. It's really nice to be here in Amsterdam. I was here a few months ago. It's my favorite city. I would like to move here one day, honestly. The last time I was here, I was speaking at React Amsterdam. I'm more of a front-end developer, and when I was there, I caught the flu on the way here. So I was literally stuck in my room sick the entire time. So I got here yesterday, and I've had an enjoyable time so far. But I'm here really for this talk, and I'm going to really just be talking about serverless. So what is serverless? I really think that serverless can be categorized into two main areas. We hear serverless, the buzzword, is getting really popular. A lot of companies are adopting it. I really think it can be categorized into two main areas. First is serverless computing, and the other is serverless functions. And I'm going to be talking about a little bit about both today. I'm going to first look at serverless computing, and then we're going to deep dive on serverless functions. So what is serverless computing? Well, unlike serverless functions, I don't think there's really a shared definition for what serverless computing is. You see a lot of people talking about serverless in the sense of what their opinion of it is and the sense of a computing paradigm, but less of a adopted definition that a lot of companies possess. But I'm going to take a look at a couple of opinions and a couple of ideas around this. The first is from a paper that was released a few months ago from Berkeley, and it was titled Cloud Computing Simplified, a Berkeley View on Serverless Computing. So in this paper, they went over a lot. They wrote another paper a year or two ago just around cloud computing in general, and they focused this paper more around serverless computing. And they said while cloud functions packaged as functions as a service offerings represent the core of serverless computing, cloud platforms also provide specialized serverless frameworks that cater to specific application requirements as backend as a service offerings. And I think we're starting to see a lot more of these platforms and a lot more of this tooling around building applications using managed services. In this case, they're calling them back-end as a service offerings, but there's actually quite a few that would fall into this bucket of managed services. And their main conclusion was this: put simply, serverless computing is now equal to functions as a service plus backend as a service. I think what we typically hear about, or when we think about serverless computing, we're thinking mainly about the serverless functions, but really we're moving more into this paradigm of serverless computing being more of an idea versus an actual specific implementation of a single idea. I also really like this blog post from Ben Kehoe, who is a research engineer at iRobot. In iRobot, they make those Roomba vacuums that kind of move around, and their entire platform is built on serverless. He wrote a paper, and he kind of talked about what isn't the point of serverless. And he said functions are not the point. While functions as a service allow us to kind of build and deploy business logic without handling all of the server patching and updating, the functions themselves are not the point. Managed services are great. They allow us to kind of build out a lot of really essential back-end services that we don't have to write from scratch anymore, but they're not the point either. Reduced DevOps is not the point. Cost is not the point. All of these things are really important, but they're all just part of what serverless means. And to him, at the end of the day, at the end of this blog post, he kind of was talking about the point is focus. With serverless computing, you can kind of worry about focusing on business logic. You can worry about building features, fixing bugs, and not worry about dealing with all of the underlying implementation details, infrastructure, and all of that stuff. So basically, serverless is a way to focus on creating value. And what we typically thought about in the old days, before a lot of this stuff that started happening over the last few years, we typically would bucket developers either as front end or back end or full stack, right? And these things were really separate. A client-side developer is writing UI logic and maybe a little bit of business logic on the client to work with data that came from an API that was actually implemented by a back-end developer. But what I think we're seeing is this abstraction that is being introduced, and we're kind of seeing the difference between a back-end, a front-end, and a full-stack developer being abstracted a little way, out a little bit. And it's kind of harder to tell the difference between what a full-stack developer is, between what a front-end and a back-end developer is. Because we can now take advantage of a lot of these managed services and build out these massive applications that typically would have required quite a few specialized engineers to implement a lot of this functionality. And when we talk about serverless functions, we're really talking about a managed service. They're functions as a service. We're buying into a function implementation that can be executed by the cloud provider that we're working with, but they deal with all of that stuff for us. And we're seeing an explosion of as-a-service things that are available to us. They started out, 5 or 6 years ago, we started seeing things like Firebase that came out. But now, not only do we have APIs as a service, we're seeing things like, like I mentioned, databases as a service, chatbots as a service. We're seeing a lot of stuff even now in the machine learning, artificial intelligence space, and AWS has things around VR and AR as a service. So a lot of this stuff is now being, continued to be offloaded into these managed services. And you can then just hook into these APIs and work with their implementation and not worry about the actual implementation details. So, again, what typically would have taken an entire team of front-end developers, back-end developers, DevOps, and everything in between can now kind of be done by a single developer. A single developer can build out an authentication flow using something like Auth0. They can build out their client-side application as well using JavaScript, and they're hooking into this using JavaScript. They can also build out their database using something like Firebase. They can then, add machine learning services from AWS, and all they're doing is hooking into an implementation that someone else wrote, and they're just buying into that API. So that's serverless computing. Let's look at serverless functions, or functions as a service. Serverless functions typically do have a shared definition, and this is kind of like a really small, basic definition of what I would call serverless functions. And this is, kind of, again, a shared definition. They basically run in stateless compute containers. They're event-driven. They're ephemeral, which means they're very short-lived. They may only last for like a single invocation, and then they go away. They're fully managed by the cloud provider or service provider of your choice. They scale. You don't have to deal with scaling, and they don't require any server ops. So why am I here? What is the issue then with building these applications? And I think this really is a really interesting tweet by one of the smartest people that I follow on Twitter, Avdi Grimm. He sent this tweet out, and he was doing a Twitch stream, and he said that he spent 3 hours with one of the smartest engineers that he knows with help from viewers on Twitch, and it took them 3 hours to get a basic Hello World Lambda function up and running. And so these are two of the smartest people, to me, I think, in the programming world, and they had this much of a problem. Imagine the average developer or someone new to cloud computing. This is a problem. And that's kind of what I'm here to talk about today. I really want to talk about how you can work with serverless functions across not only the cloud providers, but a lot of the other different ways that you can work with serverless functions using other abstractions, other services that are out there today. So I'm really going to kind of start at the cloud provider level and kind of look at a bunch of different options. So my name is Nader Dabit. I'm a web and mobile developer. I'm also the author of React Native in Action from Manning Publications and Fullstack Serverless from O'Reilly Publications. The second book, Fullstack Serverless, will be out in July. I'm a podcaster, so I'm on the React Native Radio podcast, the React Roundup podcast, and the GraphQL Patterns podcast. I'm really typically more involved in the front-end community around React and GraphQL, but working now with serverless technologies over the last year and a half, I've been writing a lot more server-side JavaScript. I also do quite a bit of blogging. I really liked Paolo's way of putting Twitter, GitHub, and Medium whatever, so I stole that a few minutes ago. But I'm Dabit3 on all the social media platforms. I do a lot of tweeting about this stuff. So we're going to go ahead and get started. The first thing we'll just take a quick glance at as a typical what a typical serverless function might look like when you look at an example and kind of what everything that goes on here is. You typically will have an export that will be the function invocation entry point. So here we have an exports.handler. This is a very typical way of naming your function. You might see this in a lot of documentation. And typically there'll be a couple of arguments into this function. A lot of times you'll see an event and a context argument, but these arguments really differ depending on the cloud provider that you're working with and the event that you're working with. Here we have a basic look at a Lambda function. This is pre-Node.js 8.5 8.10 when we were still using the callback. So basically, you have an event, a context, and then the callback, which would allow you to then return from the function. You pass in an error as the first argument, and whatever data you'd like to return as the second argument. As of Node.js 8.10, we're now able to use async await, and then you can also just return now from the function whatever data you'd like. So we're getting rid of that third argument. You don't no longer need any callback. If you have something that you want to return, you just return from the function. And then I think Microsoft Azure, and again, different cloud providers have different implementations of these functions. So this is a look at an Azure function where you have a context and a request argument. And when you're ready to return, you either call context.response or res, or I think it's context.end. So a couple of other different ways to return from a function. So what are the event and the context that are passed in as the arguments? The event really kind of depends on what triggered this function. A lot of times when you think about serverless functions, you assume like an HTTP endpoint or some type of URL was hit and that invoked the function. But there are a bunch of different ways to invoke a function that we'll look at. But say, for example, this is an event object coming from an HTTP endpoint that invoked this function, maybe through an API gateway. So you would have data in this object like the body, the query string parameters, the headers, the HTTP method, and the path, for example. But again, this object would be different depending on the function invocation event that was, invoking the function. So for example, if an image was uploaded to S3, for example, you can trigger a function and the event would have information about that image. So different event triggers that you might use other than HTTP would be storage, upload, or updates. So within Amazon S3, also from other cloud providers, you can trigger a function when an image is uploaded. And a lot of times then you'll do like image processing. So you'll maybe like resize the image and then store it somewhere. A database update. DynamoDB, and I think for Microsoft, they have their storage database that you can trigger events from. An authentication event, so a really popular use case is a user signs up. You want to put that user in some type of group for authorization purposes. So this person might be an admin, or they might be a student, or they might be whatever group. You can basically put some business logic in your function, and then when the user signs up, you then call that function, and then that function places that user in some type of group. WebSockets, Alexa, that's a pretty cool trigger. You create an Alexa app. When someone works with Alexa, you then call the Lambda function. So that's the event trigger. The context has information about the invocation, the function, and the execution environment. So this is an example of what context might look like from an AWS Lambda function. You would have the identity if the user was signed in. You would have the function name, the function version, memory limit, and megabytes. And this is kind of like a subset of the actual context. There's actually more values that are there. And again, you can kind of look at the documentation on whatever cloud provider that you're working with to get more info about the context argument. So what are the levels of abstraction? I think this is my categorization. This isn't like any standard thing, but I think I put these into 4 buckets. There's the base level that's going directly to the cloud provider and going into the console and creating your function there. There's now developer experience focused abstractions that you're seeing from places like Microsoft Azure, where they have a really nice VS Code plugin. And my company, AWS, we have AWS Amplify. And I think we're going to be seeing more of these because people at the companies realize that it's a hard learning curve to get into this stuff. You also have config-based abstractions, things like the serverless framework, Terraform, SAM, CloudFormation, things like that. And then we have a new burgeoning startup ecosystem around making this easier. So it's so hard that startups are literally coming up to make this easier and making money doing it, because that's just how big of an issue I think it is. So things like Apex, I'm sorry, that would be more in the config. So things like Zeit now, things like Nellaphi functions, for example. So we're going to look at all of these different layers of abstraction. So we'll first take a look at the service provider level. So you can work with functions from all of the main cloud providers at this point. So there's Azure functions, there's Lambda functions from AWS, there's Google Cloud functions, and I think IBM even has something around serverless functions as well. So we'll take a look at a couple of examples, how you might go into the dashboard and actually do this stuff. So this is what GCP looks like. You go into the dashboard, you click create function, you get this view, you give the function a name, you allocate memory, you specify a trigger. So for instance, this could again be a trigger from DynamoDB for AWS or for whatever database that they use. You can specify the runtime. So this is basically the language. You could specify Go or whatever is supported by the platform. And then you would write your function code, and then you would be able to specify dependencies in a package.json, and you can just write whatever code you like, and then you can just click create. That's how it looks, with GCP. AWS looks something like this, where you go into the console, you click create function, you give the function a name and a runtime, and then you can kind of like either start from scratch or start from a boilerplate. And then from here, you can either edit the code in line, or you can upload like a zip file that holds your node modules and all of your function code. So what are the pros to working directly? I think if you go directly into the console, it's actually pretty easy just to create a function, but that's kind of where it stops, in my opinion. There's really no way to scale this for large projects or teams. So a lot of the people that start playing around with it at this point, they move on to something else later on for real serious projects. Next, we'll look at the developer experience-based abstractions, and these are my favorite ones right now, mainly because I work on the Amplify team. But I'm also going to show you Azure VS Code extensions, and we're going to demo that because I think that's a really cool implementation. So right now, the three main ones that I see are Firebase, Azure VS Code extensions, and Amplify, because these are again coming directly from the service providers. So Azure has this VS Code plugin that you install, and then you get this little icon here at the bottom left. You have two things at the top now. Once you click on that, you can either create a new project, or you can add a function to an existing project. So if you click on this button that I have highlighted there, that will be to create a new project. If you wanted to add a function to an existing project, you just click that lightning bolt. So I think to demo this would be better than just talking about it. So let me go ahead and pull up a demo real quick. And close that. All right. So go ahead and open this up in my text editor. And make sure the font size looks good. Okay, cool. So this is like a really basic empty project. So we look here, there's nothing there. We're going to go here, click this icon, and we want to create a new project. So we click on that. And now we want to select the folder that we'd like this project to be in. I'm just going to make it in the root level of this folder. I want to choose JavaScript, Python, or Java, or whatever. So we'll go with JavaScript. We can choose now the trigger that we'd like to invoke this. So for us, we'll choose HTTP trigger. We can now give this a name, and I'll call this test function. And we can now add authorization, which I'm not going to do. I'll just use anonymous. And once that's done, we'll open the folder, and we'll see that we have a couple of different files, or actually a bunch of different files that were created. We have package.json, we have a bunch of configuration, and then we have our actual function, which is written in this text function folder. And here we have our index.js, as well as some data that we can work with to pass and to test out events and things like that. And we have some more configuration. So in the index.js, we have our function code that's kind of like boilerplate that they kind of give us to start off, where we check if there's a query name. If there is, we return a message that has that query name along with hello. If there isn't, we just return a body that has a message saying, hey, you should add some type of query string. So let's run this function as is. So again, another part of this extension is you can just press F5, and this goes ahead and builds the function for you and then deploys it locally on localhost. So once that's done, we can just click on this button here. This opens up the function URL, and we now see that we get our message that says, please pass a name. So let's go ahead and pass a name of world. Oops. And there we go. We see a hello world. And if I put my name, we would have hello Nader. So basically what's going on, it's returning the request query name or the request body name. So that's pretty easy, right, to get up and running. What if we want to deploy this into the into our back end, have it live? Well, there's a button here. You would just click this button, and this would deploy into your Azure account. The function would be live. You would have a live HTTP endpoint, and the function would also be deployed. So that was super easy, right? That's a really nice experience. This was, part of what is offered now by Microsoft because they're trying to make this easier as well. So that's kind of a look at that. And next we'll look at a couple of other demos. Next we'll look at AWS Amplify. This is the team that I work on. We have the Amplify CLI that allows you to add features and services. So to add a serverless function, you would just run amplify add function. If you wanted to add an API endpoint in front of that function, you would run amplify add API. If you wanted to deploy it, you would run amplify push. If you wanted to invoke it locally and test it out, you could run amplify function invoke and whatever function name that you'd like to test out. All right, let's do another demo. I'll go back to this. And actually, I don't think I need to even open up the text editor from here. We're going to work directly from the command line for now. So I'm in this AWS folder. I'm going to run amplify add API. Is that readable for everyone? All right, amplify add API. This is going to walk us through a couple of steps around the function that we can now create from our command line. I'm sorry, I need to add the function before I add the API, don't I? So let me run amplify add function. So we'll add the serverless function, and then we'll add the API in front of it. So I'll call this test function. We'll give the Lambda function a name in the category local reference a name. So we give the reference a name of test func. We'll also give the Lambda function the same name. We can have 3 boilerplates to choose from. One is a hello world function, basically an example like we looked at earlier. You can also choose a CRUD function with CRUD functionality built in to work with the database, so create, update, delete, and lists and things like that. Or we can create an express server running in a function. So I'm going to choose the hello world because it's pretty basic, and it's going to ask us if we'd like to edit it. If we want to take a look or edit it, we can go ahead and choose yes. Oh, I'm actually jumping ahead, so let me start that over again. We can associate this function with other services and things like that, so I don't want to do that for this demo. So I don't want to associate with this other features, but I do want to edit the function. So this is where I'm going to choose yes. So this gives us this function here. And we're basically calling context.done. And we're passing in null as the first argument and whatever we'd like to return as a second argument. So instead, maybe we'll create some data, and we'll set this to something like sorry about that. So instead of passing in that, maybe we'll just pass in the data. So yeah, and now that's it. The function's created. If we want to test it out, we can run amplify function invoke. I think that's the name of the function. Okay, now we can specify where that function lives. So if we had changed the name of the file, we would specify that there. By default, it's index, and by default, the function name is handler. And when we test it out, we see success, and we get the data that we returned. So what if we want to put an endpoint in front of it? We can run amplify add API, and here we can add either a GraphQL API or a REST API. So I'm going to choose REST. I'm going to provide a name for this. Call this test API. Now we can provide the path that we'd like to invoke this function with. So I'll call this /test. So we can basically call this API /test to invoke this. I'm going to use a Lambda function already available. and now it'll just prompt me for that function. So we just choose the test function. If we'd like to restrict API access with authorization, we can say yes. It'll actually create the authentication service for us. But since we don't want to do that, we'll just choose no, and we don't want to add another path. And that's about it. If we want to now deploy this into our account, we could run amplify push. I don't really want to do that. It doesn't really matter, but for a demo, I'm not going to do that. Okay, cool. So that's amplify. We're going to have one more demo in just a moment. But for now, let me jump back to my slides. So what are the pros of using some of these DX-focused, examples or VX-focused tools? It's a really low learning curve. You saw how quickly we were able to get up and running with this. It's really quick to work with, and it's really easy to deploy these. You saw one-click deploy with Microsoft, and we saw that there was just one command we can run with Amplify. Firebase is also really easy. So it's a really nice user experience. I think the cons at this point is these are not yet at feature parity because these are just abstractions that are on top of something that is, very complex underneath. We're not able to keep up with all the different feature set. And a lot of these are new. Amplify is new. That plugin's fairly new. There's just not everything that you would be able to do with a directly from the service provider level or using some of these config-based abstractions using these DX-focused abstractions. So the next are the configuration-based abstractions. And these are, there's a few main ones. So I have serverless framework here. I think someone gave a talk earlier that mentioned serverless, kind of went over that. There's Terraform, there's Apex, and some of these not only allow you to create serverless functions, but they allow you to do a lot more stuff within the cloud. There's also things like SAM and CloudFormation, but those are AWS specific. These actually will work, I believe, at least Terraform and serverless with any framework or with any cloud provider. So how would this work with serverless framework? If we wanted to create a new function, we could just say serverless create, pass in the location and the type of function that we'd like to create. So if we'd like a Go runtime or a Node.js, we would specify that here. That would create two files. So for example, if we ran this with Node, we'd have a serverless.yaml file, which is configuration, and then we'd have an example boilerplate Node JavaScript function to start with. The function would typically look something like this. In fact, I think this is exactly what's created. You basically have an async function that's returning an object with a status code and a body. And then you have this configuration that you have to kind of work with. And I think this is the problem getting started with working with the serverless framework and some of these configuration-based abstractions, but they're also the most powerful reasons that you might want to use these, because you can specify everything here, and you can do a lot with this stuff, and it's really powerful, and a lot of companies and teams use it because it's easier to keep up with, because you're dealing with configuration or what they call infrastructure as code. But it's really hard, I think, for new people, new to the cloud, new to cloud computing in general, to get started with this, because there's a lot of jargon, there's a lot of things that you have to know, and if you don't know what that means, it's kind of hard to get going with it. So the pros and cons, it's easy to deploy these. You can deploy these directly from your command line typically. They're pretty easy to update if you know what you're doing. And they're really great to work with for teams, but there's a very steep learning curve for most of these. I think serverless framework has the easiest entry point. Terraform and some of these others have a little bit even steeper of a learning curve. And some of these only work with AWS, so if you're not interested with AWS, you're not able to use some of these. So for instance, SAM, I think Apex, and I think CloudFormation, actually I know for sure CloudFormation, I believe only work with AWS. And then now we're seeing these second layer clouds. And I recently listened to a podcast with Guillermo, who is the person behind Now. And he really talked about really in depth what his philosophy is around Now. And I think it goes along with what this talk is talking about. So I would definitely recommend listening to that episode. I think it was out in February. Guillermo Rauch, he's on Software Engineering Daily talking about Now. But we're going to look at how Now and Nellaphi work. And these are kind of like third-party abstractions, I would say, that are built on top of an underlying cloud provider. So Nellaphi looks something like this. If you wanted to create a Nellaphi function within your existing project, you would just install the Nellaphi Lambda dependency. You would make a directory where you would specify all of your functions are going to go. So in this example, I'm calling this lambda, but this could be whatever. And then you create your first function. So I'm creating a function called hello-world.js. Because it's in this lambda folder, that's going to be deployed as a serverless function. And then we specify our configuration file, which in this case is a really basic configuration called nellaphi.toml. The nellaphi.toml has the command for building the functions folder definition, or the reference for the functions folder, and then the folder where the when the actual functions get built, what folder you'd like to build those in. So we're basically saying we want to build these in a build folder. The command to do that would be yarn build, and the function location is in the lambda folder. When you create your Nellaphi function, it would basically really be a basic serverless function, similar to what we've looked at before, where you have an event, a context, and a callback. To return from this function, you would probably, I believe you have to use callback. I'm not positive if you can use async await if node.js 8.10 or whatever is available. I would assume that it is, but based on my quick research on this, this is what I found. If you wanted to test this locally, you could run Nellaphi lambda serve, and then the name of the folder. If you wanted to deploy this or build this, you could run Nellaphi lambda build with the name of the folder. And then there's also a project that's called Create React App Lambda that will do Create React App and then add all this configuration and stuff for you to give you like kind of an example project to start working with Nellaphi. Now, we'll look at Now. So Now is a part of Zeit. They also have the framework for JavaScript that you've probably heard of, Nuxt.js, server-rendered JavaScript. So this is probably the simplest way that I've found really to kind of get up and running with this stuff. You install the global Now package, and then you now have this Now binary you can work with. You create two files, the configuration, which is now.json, which is very concise, and the function, which would be index.js. The index.js, for the most basic of hello worlds, would look something like this, where you have the return for this would be res.end. I'm not positive if this is now specific, but I believe it might be. So you have the request and response. So this kind of looks just like a node, a node function, as opposed to like what we've been seeing really around what these typically have serverless function specific stuff. So you create your basic function. If you want to return from it, you pass in whatever you'd like to response.end. And then the JSON will have a builds array. And in this array, you can specify all of the different functions that you have. And you can specify runtimes for each function. So you don't have to only build in JavaScript. You can build in Go and all these other whatever is supported. So you could have an array with 7 or 8 functions, and you could specify the execution environment. And then to deploy, you would just type now from the directory that you're working in. So let's deploy one of these real quick. So what I have here is this index.js and this now.json. It looks exactly like we looked at in our slides just a moment ago. We have now.json with this array of builds, and we have index.js. That's our function. So again, if we want to deploy this, we just type in now. This deploys the project, and it does it pretty quickly. And we're going to see it gives us an endpoint that we can now test out, and this is like a live endpoint. And I think the execution for the build with Now is probably the quickest of all of the ones that I've used so far. So if we want to test this out, we can click on this alias URL. Well, let me just copy and paste this. There's something weird going on with my keyboard. So if I go to Chrome and I start this up, we'll see that we have Hello World. Okay, that was pretty easy, right? All right, so that was the demo. So very low learning curve for Nellaphi and for Now and for any of the others that would fall into this category. and I think you're going to see a lot more falling into this category. Very good developer experience, really nice to work with, really fun to work with. The cons, because these are the cons because these are kind of like my opinion, not coming from any cloud provider or any of these companies themselves, but because they're built on top of these existing cloud providers, I think you might run into a higher cost. That's the possibility. And because it's a higher level of abstraction, you might not be at feature parity, very similarly to the DX-focused ones that I kind of talked about earlier. So to kind of recap everything, these are like my main points, I would say. Serverless, the idea or the paradigm is a way to really focus on creating business value as opposed to just writing serverless functions. I think the client and server are moving closer and closer together, and you're going to see a lot more tooling coming from not only cloud providers but third-party providers to enable developers to build these type of applications. And the abstractions that we went over today are kind of like falling into that category, and I see that ramping up quite a bit in the future. I really like Guillermo, and I really like this quote that he said, serverless is king. I think because we're seeing so much adoption of the serverless paradigm in general, you're just going to see a lot of growth in this industry. And we've already seen quite a bit of it. So it's a really good opportunity, I think, if you want to get in on something that is going to continue to grow. And not only do I think serverless is the future, I really believe this idea of full stack serverless is the future. The idea of bringing the client and the server and these managed services kind of closer and closer together. Whereas developers, we're going to stop being back-end developers. We're going to stop being front-end developers, and we're just going to be developers. And that's it. Thank you for watching my talk.